Okay, this is part 3. There's another example, and let's try this one together. Okay, so a company makes 2 types of boats. They make aluminum boats and fiberglass bow riders, whatever that is. If you're into boats, maybe you know what that is. When both assembly lines are running at full capacity, they can make a maximum of 20 boats per day. Okay, the demand for fiberglass boats is greater than the demand for aluminum boats. So the company makes at least 5 more fiberglass boats than aluminum boats each day. Okay, variables. Let's make something up. Let's make X aluminum boats. And let's make Y fiber glass boats. Okay, our equations. We know that we can make a maximum of 20 boats per day. So if I take all my boats together, they can be less than or equal to 20, but not greater than. That's equation 1. We're always going to have 2 equations here. Equation 2 is going to be this. We know that if I take all the fiberglass boats and I subtract all the aluminum boats I made in a day, there's always going to be a difference of 5. Because we're always making at least 5 more fiberglass boats than aluminum boats. So if I made 15 and I took away 10, or that would be too many. If I had 10 and I took away 5, we're always going to have a difference of 5. Because you're always going to have 5 more fiberglass boats. Don't understand that? Pause it and watch it again. Okay, restrictions. Remember, what can we have here? X and Y have to be whole numbers. So that's your elements. That's your fine-tuning. What I should have written first was that X and Y have to be greater than or equal to 0 for the same reason as before. You can't have negative boats and you can't have part boats, which is why you have to have whole numbers. Okay, those are your restrictions. Now, how do we graph it? Exactly the same way as we did before, and I think this one actually works out a little bit better. Okay, so on my graph I've got here, I did the same sort of thing. On the x-axis, I'm going to put all my x values. X, we made aluminum boats to a maximum of 20, because you can't have more than 20 boats in a day. And I made each square equal to 1, so 5 for 5 squares. And for the y, I put all my fiberglass boats up to a maximum of 20. And I'm going to graph these values. So I list my 2 inequalities. So that's the first one. The second one I got as y minus x. Okay, and then to use the x and y intercept thing again. This time it actually works, I believe. So I'm going to make x equal to 0, and I get y equal to 20. And then I'm going to make y equal to 0, and x becomes 20. Now I've got 2 points. Remember, if you don't understand x and y intercept, you better go back and figure that out from the previous notes. I think that was from the very first lesson and from the stuff that we were working on together. I do the same thing for x and y. When I make x 0, y is 5. When I make y 0, x is negative 5. Now, can you use that one? No, because we know that point doesn't exist in reality. Because if I have 0 fiberglass boats, you're not going to have negative 5 aluminum boats. It's not possible. So pick another point that would be found somewhere on here. So what I'm going to pick is, let's make y 15, let's say. So when you plug in y 15, I get x 10. You might have to pick another point that fits, but you can choose any point. So in this case, this didn't work because that's not possible. You can't have negative boats. So I just picked another y value that would be found somewhere in here. Like, don't pick y like 100 because it doesn't fit on the graph. Pick something that fits in. Okay, now I've got 2 points. When I graph the first one, 0, 20 is there, 20, 0 is there. When I graph the second one, I get 0, 5 and 10, 15. So 10, 15. So my second graph looks like that. Remember, use a ruler. And then my first graph looks like that. That's pretty pro. That looks horrible. Okay, so now we have to take a look. We know the values are less than, so the y value is less than. There's a positive y, so we're good. There's a positive y, so we're good. And they're less than. In this one, it's greater than. Oops, my bad. This one's greater than. Okay, so for this one, the y values have to be less. So that's this graph. And we do it solid because there's also equals. So the y has to be less than. So if I were shading, it would be like all of this if it was less than. Okay, so I have to be careful here. So if I shaded all of this, it would be all of this region if we had one graph, this graph here. But I can't. This one is saying y is greater than 5, so I'm supposed to shade everything above. So if I shaded everything above here and everything below on this graph, where do they overlap? The only place where they overlap is here. Now, if you have troubles with this, here's a good little hint. Use 2 different colors pencil crayons. Use blue. So if I went y is less than 20 and I shaded all of this here, all of this region would be blue. Here, if I went y is greater than 5, I would shade all of this region yellow. Wherever they overlap, turns green. This is the only place they overlap. So that is your solution set. This is your discrete values. Okay, and this is your common region. So if you don't understand that, pause the video and watch it again. Okay, so the final thing is which combination of boats should they make? So you can pick any value that's whole number in here. So I could pick 15, or I could pick a dot like 5 and pick it in here, right? And you could figure out what this would be. So I could pick a dot right there. That works, because that would be in the solution set. So that would tell you x would be equal to 5 and y would be equal to 11. That works. But you could not do something that's outside of the solution set. Like you couldn't pick a point here, you couldn't pick a point there, you couldn't pick a point there. That's all that's asking. Okay, what I'd like you guys to do is practice these solutions sets by doing the same thing. Use x and y intercept and figure out what you get here. Now they've given you the equations already, so they've kind of done half the work already for you. So you don't have to write the equations. All you've got to do is graph the solution sets. So here, do your x and y intercepts, draw what you get. Here, there's no restrictions. You can have negative numbers, right? And there is no restrictions in terms of whole numbers, so you can shade everything. So here I want you to go in and actually figure out what you get for your answers. And do the same thing for the next part, which is taking a look where you have more than one solution set. So when you have more than one solution set, you're going to have 3 lines. And wherever you have 3 lines, you're going to have one spot where it overlaps in all of them. So these ones might give you a little bit more trouble, but you can definitely try them yourself, and we'll go over them next time I'm in class. That's your assignment. Do I want you to do all of them? No, I want you to do these ones here. I will check the homework, and you will be responsible for it. If you're stuck, you can always email me. I may not be at school tomorrow. I'm not feeling too great, but it doesn't mean that you can't email me. So I'm taking it upon you to contact me if I don't understand any of these concepts. Please make sure that you get this work done. I definitely will be checking.